I'm in Minitab and I'm looking at testing one mean with the hand grip strength data set. Before we start looking at the data and doing it, or before we do a test, let's look at the data. So if we go into graph and histogram, we'll just remind ourselves what this data looks like, and we've looked at this in a previous tutorial, I think. So we're going to do a histogram with a fit because we want to see if it's approximately normal. So let's see here, hand grip strength. Wonder if there's any options that I want to have a look at here. I don't think so. Let's just do that. Okay, so what we've got here is that might be more convenient to have a few more bins in there. So binning, number of intervals, let's bump that up. Let's double it to 16. Okay, I feel happier with that now. So we've got it's sort of normal in that it has a peak and then it tails out. The problem we've got is that it stops at 0, so this is what we would call a truncated normal distribution. And the reason it stops at 0 hopefully is obvious, and that's because you can't have a negative hand grip strength. All the values have to be positive. Now, whether or not this is going to affect our analysis, I don't think it's going to matter too much. The tests we're doing are fairly robust. We would say that we would interpret the results with caution because the data is not quite normal, and if you're interested, there is a formal test of normality which we might get up to actually in a later week, but for the moment it's okay just to draw a histogram with a normal distribution over the top of it, a normal curve, and just have a look at it and see if it looks approximately normal. And that's not too bad apart from this stopping at 0 business. So the idea is that we can test the value of the mean hand grip strength. Now we might want to do this if we are comparing our results with somebody else's research. So if somebody else had already done a study on hand grip strength in UK residents aged over 65, and they found that there was a mean hand grip strength of 29.5 kilograms, we might want to see, well, is our group of people similar to that group of people? And that's called testing one mean. So we want to know, is the mean overall significantly different from 29.5 kilograms? And just looking at this histogram, I'm thinking, yes, it probably is, because 29.5 is way out here on the tails, and it looks like our mean is much further down here. But let's do the test. So we're going to go to Stat, Basic Statistics. Now we've got a few choices here. We don't go into the mathematics behind any of these tests, and so the reasons for choosing one test over another may not be immediately obvious. We are using a one sample t-test. That's this here, 1t. It's just popped up on my other monitor, so I'll drag it across. So we want to have a look at the sample in the column average hand strength, and we want to perform a hypothesis test. Now, if you remember from the textbook, the null hypothesis must be very precise and it must be specific. We can't test something vague, and that's because the computer has to be able to do the maths. It has to be able to calculate probabilities, and it can't do any of that on a vague statement. So we have to give it something specific to test. Often we're testing to see that our test is that things are the same or that the difference is 0. In this case, we're testing to see if our mean is equal to 29.5 because we want to see if our data is the same as this other research paper. Now we can get it to do graphs. We've already done one, but if you wanted to do it all together, you could do it here. So we could have a look at a histogram and a box plot if we wanted. Okay, what other options do we have? And options. Confidence level, again, 95% confidence level, that's fine. If you wanted to, you could bump that up to 99, or maybe you could drop it down if you didn't need to be quite so confident to a 90% confidence interval. Our alternative, if we're going to use our two-sided alternative, that it's not equal to that. Okay. This is why I like Minitab. I really like the graphs it does. So let's have a look here. This is beautiful. Love it. So we've got X bar. So this is our mean for our sample. This is a 95% confidence interval for the mean. So we're 95% sure that we are covering the true mean for our population with this sample mean. And our test value, H0, is way out here. Long, long way from our sample. So just based on this graph, it looks like we would have very strong evidence against the null hypothesis that our mean is equal to this. It does not look like our true population could be anywhere out here. So that's a lovely plot. And again, we've got a histogram with the same thing on it, the X bar and the H0. Everything's very slow when I'm recording, so it takes me a little while to drag things around. Okay, so that's the plots. Let's have a look at the actual test. So mu is that character that we write out for the Greek character mu for the true population that mean that we're testing. So we're testing to see if mu is equal to 29.5 versus it's not equal to 29.5. So this is our null hypothesis here, and this is our alternative. Our variable is average hand strength. We have N56 in the sample. Our mean is 9.46, standard deviation, standard error of the mean, 95% confidence interval. So that's everything that we could see on the graphs. And now we get to the actual test, which is here. T is our test statistic. You will often see T values quoted in papers. However, the T values go along with the P values. Because we don't look at the maths behind the tests, the T value is not going to mean very much to you, and you can probably ignore it for the most point. The further this T value is away from 0, the smaller our P value will be, if you're interested. So our P value is the probability of getting this data here if our null hypothesis is true. Now this P value is pretty much 0, very, very close to 0. Therefore, there is very, very small chance of having got this data if the null hypothesis was true, and therefore the null hypothesis is probably not true. So we've got very strong evidence against the null hypothesis. We've got very strong evidence against the mean being 29.5, and therefore the mean is probably not 29.5. Now you'll notice that the test is a little bit vague in the alternative. And it doesn't actually tell us what the mean is, it just tells us what it's not. So it's probably not 29.5, we've got very strong evidence against that. Then if we want to make a claim about what the true mean actually is, we would have to look at our confidence interval to do that. So if we were comparing this to another data set where they found that the hand grip strength was 29.5, we might question whether we were really looking at the same group of people. Are we all looking at people aged 65 or over in the UK, or are you looking at a special group of people and we're looking at someone different, because we've got very, very different means here. So that's a one sample t-test, and in the next video we'll have a look at comparing two means in the same data set.